It's easy to measure the mass of everyday items. A juice carton, a loaf of bread, an apple. But how do you measure the mass of something much, much larger, like the sun? To determine the sun's mass, let's use an approach we'll call the orbital method. We can calculate the mass of the sun by measuring the orbital speed and radius of one of the planets, such as Jupiter. Jupiter orbits the sun at 13 kilometers per second. The shape of Jupiter's orbit is essentially circular, with a radius of 780 million kilometers. So how can we use these two numbers to calculate the sun's mass? Let's start with Newton's second law of motion, which says that the net force acting on Jupiter is equal to its mass times its acceleration. The net force is the gravitational force the sun exerts on Jupiter. The magnitude of this force is equal to the universal gravitational constant times the mass of Jupiter times the mass of the sun divided by the square of the radius of Jupiter's orbit. Because Jupiter moves around the sun in uniform circular motion, we know that its acceleration is directed toward the sun and is equal to its speed squared divided by the radius. So if we substitute the gravitational force and Jupiter's acceleration into Newton's second law, we get the following formula. If we want to know the mass of the sun, we rearrange the formula. This formula shows there's a relationship between mass and orbital speed. When we substitute in the speed and radius of Jupiter's orbit, we can complete our calculation of the sun's mass. So what does this number really mean? Only that the sun is 1,000 times the mass of Jupiter and 300,000 times the mass of Earth.